Welcome back, physicists and earth space scientists, continuing on with the NCEA Level 1 External on Heat, and today looking at the concept or idea of latent heat. So we've already looked at the different states of matter. So basically matter can exist in three different forms, either solid, liquid or gas. Okay, so looking at the context of water with this visual here, we have solid ice and it melts at a melting point, 0 degrees Celsius, to form water, okay, liquid state. Then it vaporizes to form steam at the boiling point of water, about 100 degrees Celsius. And then as it goes below 100 degrees Celsius, it condenses at that point, going back into water. And then that water is solidified again at the freezing point of water at 0 degrees Celsius, back into solid ice. Okay, so that's your changes of state. But we also need to consider the energy involved in these processes. And that's where latent heat comes in. Okay, so what is latent heat? So latent heat is essentially the thermal energy that causes this change of state. Okay, without a change in temperature. And I hear you ask, well, why is there no change in temperature? Because remember, temperature is about the average kinetic energy of the particles. Okay, so when a substance changes state, say from a solid to a liquid, then the heat energy is actually used to break the bonds between the particles. Okay, so the particles are not moving, there's no increase in kinetic energy, so there's therefore no increase in temperature. All that heat energy is being used for is to break the bonds between the particles. And there's two kinds of latent heat we're going to look at today: the latent heat of fusion and the latent heat of vaporization, as you can see from the diagram there. So another concept in this general area is the specific latent heat. Okay, so when energy is absorbed by a substance, okay, the temperature of the object does not necessarily rise if that heat energy is being used to break into particle bonding. Okay, so what happens is that the thermal energy causes basically the substance to change from one state into another. And the amount of energy that's required to change a substance into one state into another is called the specific latent heat of the substance, because it's specific to that substance. And the equation is the thermal energy required equals the mass of the substance times the specific latent heat. And there are two types of specific latent heat we're going to look at. The first one is the latent heat of fusion. So that happens when you are melting solids. So when you melt a solid, it means you're going, of course, from a solid to a liquid. Okay, so in the beginning, a solid, so it's all nice and rigid and in place and only vibrating around it, basically in its place. Okay, the particles just vibrating in a particular position. Okay, and you need to be able to break up those interparticle bonds in order for the substance to form a liquid. Okay, so it has to be freed from that rigid structure. And that requires putting in some heat energy, and that's known as the latent heat of fusion. And conversely, if you want to have a liquid and go into freezing, so you have to therefore remove heat energy in order for the particles to lose that kinetic energy and begin to form that rigid structure again. Okay, so it goes both ways, back and forth. So in terms of the latent heat of fusion, so you're absorbing the heat, so it has to be a positive addition of energy. And so when you're going from a solid to a liquid, liquid to a solid, the sample must release its heat. Okay, so that's going to be negative. Okay, so the heat energy of the phase change is known as the latent heat of fusion, LF. So the equation's the thermal energy equals the mass of the substance times its latent heat of fusion, and it can be either negative or positive, which we'll look at soon. So the next one, in terms of latent heat, is the latent heat of vaporization. So that's when we're talking about a liquid going into a vapor. Okay, so it's going from a liquid state into a gas state. So this requires, of course, energy, because now the particles must be freed of their liquid state. They no longer flow. They must be spread far and wide because they're now gases. So there's no interparticular particle bonding anymore. And conversely, going the opposite direction, condensing a gas into a liquid is the reverse of it. It means that heat has to be removed from the gas in order for the particles to all go together and cluster together and form those interparticle bonds. Okay, and the heat of transformation for these phases is known as the heat of vaporization, or latent heat of vaporization. So it's E thermal equals mass again times, this time, the latent heat of vaporization. So we'll already look at phase changes. So we've got deposition, going gas to solid. Solid into a gas is subliming, which carbon dioxide does. We've got evaporation from a liquid to a gas, and condensation from a gas to a liquid. And finally, liquid freezes into a solid, and solid melts into a liquid. And this all requires energy changes, either energy being put in, or heat energy being put in, or heat energy being removed from the substance. So when a heat is added to a substance for melting or vaporization or sublimation, this is what occurs. And when you take heat out of the substance, then you are basically freezing, condensating, or depositioning the substance. So in terms of heating curves, you can clearly see that as you go from ice at say minus 25, it starts to melt. You can see from point B to C, there is no temperature difference because you're basically breaking those interparticle bonds at that point. So there's no kinetic energy because the particles aren't moving any faster. They're just breaking those interparticle bonds to a point. And then once they're all been broken, you get liquid water, which then increases in temperature, which is known as sensible heat, until 100 degrees Celsius, which is point D. And then that goes off into point E when you're making basically a super hot gas, but it's still a vapor. Okay, so that's known as so point B and C is your latent heat of fusion, and point D to E is your latent heat of vaporization.